Okay, so in this video, we're going to learn how to solve quadratics by factoring. And remember, factoring is when you do the t-chart or when you take out a monomial. So first you have to make sure that your equation is set equal to 0 before you factor, because you're looking for the zeros in the solutions, so the right side of your equation has to equal 0. So you could have to do some inverse operations to make everything be on the left side. Step 1 is to figure out whether you have to use a t-chart or whether you need to factor out a GCF. So remember, you're going to use a t-chart when you have something that looks like ax squared plus bx plus c, when you've got three terms that start off with an x squared. You're usually going to take out a GCF when you have two terms, like these examples down here. So you're going to set each parenthesis equal to 0. That's called the zero product property. And then that's how you're going to get your solution. So you want your answer to look like this. So then you can set them equal to 0 to solve your problem, okay? All right, so let's take a look at some examples. So in this first example, I need to find a GCF since I only have two terms. So the only thing that goes into a 3 is a 3 and a 1. And then a 15 would be 3 times 5. So the biggest factor they have in common would be a 3. So I would take out a 3. Out of an x squared and an x, you're going to take out the smallest x value again. And then you're going to divide to see what's on the inside. We're going to have two blanks because there were two terms. And so 3 divided by 3 is just a 1. X2 take away 1x is just an x. And then 15 divided by 3 is a 5. And I do not need any x terms with that one. Okay? So once you've factored it, that's when we're going to set it equal to 0. Okay? And that means I'm going to set this term equal to 0 and this term equal to 0 to solve. So one equation is going to be 3x equals 0. The other one is going to be x plus 5 equals 0. And so we're going to use our zero product property to solve to get x equals 0 for one solution and x equals -5 for your other solution. Okay. Again, you'll typically have two answers because it is a quadratic. Sometimes you may have one, but typically you will have two. Okay. So why don't you try this one on your own? So find the GCF and write it like this, and then find your solutions. The GCF was a 2, and again I took out 1x. I divided to find the inside, and I got x plus 4 on the inside. And then now I've got a factored term, so I can set them equal to 0. So again, 2x would equal 0, and you will get x equals 0. X plus 4 equals 0, and I got -4. So notice when you factor out a monomial, in this case, when you've got one term on the outside, one of your solutions is always going to be 0, okay, because you don't have a number to add or subtract with it. All right, so example 2 is the same thing, however, they're not on the same side. So I need everything to be on the same side before I can factor something out. So I'm going to move all my terms to the left side because that's how I like to look at them. So I need to move this 5x to the left by doing the opposite of a 5x, which is subtract 5x. And if I do it to the right side, I need to do it to the left side. I cannot combine like terms because an x squared and an x are different, so you're going to rewrite them. So you would rewrite them as 10x squared minus 5x. And then you now have 0 on that side because you've moved it over. So now that you've got two terms on one side equals 0, I can factor out a monomial and find the GCF. So GCF of a 10 is 5 times 2, and the factors of 5 are 5 and 1, so they have a 5 in common. Take out an x like always, and then divide to see what's in the middle. 10 divided by 5 is 2, and I need an x to get x squared, minus 1. So again, now I can set those terms equal to 0 and solve. So one equation would be 5x equals 0. My other equation will be 2x minus 1 equals 0. So divide by 5. So x equals 0, again, is one solution. On this one, I'm going to add 1 and get 2x equals 1. Divide by 2. So x is going to equal a half. Okay, So my solutions to this would be a 0 and a half. Okay. All right, so why don't you try this one on your own? You're going to need to move that 4x to the left and then find the GCF and solve. In this one, I subtracted 4x, and then I can't combine like terms, so I rewrote my problems. I found the GCF of a 4 and a 16, which is a 4. I divided to find my inside, and then I set them equal to 0. So my first equation was 4x equals 0, and I got x equals 0. My second equation was 4x minus 1 equals 0. And once I solved that, I got 1/4, or you could make it a decimal like 0.25. Okay, so that is how you solve by factoring out a monomial. And you do that when there are two terms. So let's take a look at when we need to do our t-chart. So here's an example when your a value is a 1. So these are kind of the shortcut ways to solve your equation. So again, if you have a quadratic with 3 terms, quadratic trinomial, the first thing you do is multiply a times c and do your t-chart. So you're going to multiply a times c, which is a -8, and then your b term is going to go on the right side of your t-chart. You're going to list all the factors of an 8, so 1 times 8 and 2 times 4. I need to make one of them negative to multiply to get a negative. But when I add, then I need to get a -2. So 2 minus a 4 does give me a -2, so I had to make that 4 negative. Okay, again, this is our shortcut because your a value is a 1. So all we're going to do is write these two factors in a parenthesis. So x plus 2 and x minus 4. So once you've got this, to find the solution, you're going to use the zero product property and set them equal to 0. So you're going to set the first one equal to 0. So x plus 2 equals 0 is one equation. And then x minus 4 equals 0 is your other equation. So then you're going to subtract 2 on both sides. So x equals -2 is one solution. And then add 4 over here. X equals 4 is your other solution. Okay, so that's how you factor a trinomial to find your solutions. So again, the only way it can get trickier is, for example, down here when not everything is on the same side. So you are going to have to make everything go to one side before you can do this. But why don't you try this one here and then we'll go over it. So on this thing, you're going to multiply a times c to get 15. You listed out your factors of 15 to get 5 and 3. 5 and 3 will add to get you an 8 and multiply to get you 15. So again, write those answers in your parentheses and then use the zero product property to solve. And remember, a shortcut is to change your signs because that's all that's happening when you have an x and a number. So -3 and -5 were your solutions to this problem over here. Okay. All right, so let's look at example 4. Again, they all have to be on the same side. So I'm going to do 2 different ways to show you what you can do. If I want to move everything to the left, which is how I prefer to do it, I would do the opposite of a -10x to move it to the left. So then I would have x squared plus 10x equals -24. Because again, you're not going to combine like terms because they don't have the same variable. So you're just kind of switching the sign when you move them to the same side. Again, I have to do the opposite of a 24 and add 24 to both sides. And again, I can't combine like terms. So all I'm doing is x squared plus 10x plus 24. I'm just rewriting the problem. Okay? So that's one way, is to move your terms to the left side, and all you do is change the signs when you turn them to the left side. A quicker way of doing this, if you have x squared equals -10x minus 24, the quickest way is just to move this term over here by doing the opposite, which is a -x squared. And so in this case, you would have 0 equals -x squared minus 10x minus 24. So both problems are the same. They're just either all negative or all positive. So it's up to you which way you prefer, but just make sure they're all on the same side. So I'm going to go ahead and erase this, and we're going to deal with this problem over here that we just did. So here is my new problem with the terms all on the same side. Okay, so now that the terms are all on the same side, that's when I can do my t-chart. So again, this is a shortcut. I'm going to do 1 times 24 and get 24, and then 10 will be on the right side. You're going to list all the factors of 24. 6 times 4 comes to my head first, and so actually that works because 6 plus 4 is a 10. So again, x plus 6 is going to go in one parenthesis, x plus 4 is going to go in the other. So now to find your solution, you're going to set them equal to 0. So you would have x plus 6 equals 0, and you would have x plus 4 equals 0, and you would solve each one-step equation. So x equals -6 is one answer, subtract 4, x equals -4. And again, a shortcut on these problems is you're just going to change your sign when you find the solution, okay? All right, so why don't you try this last one on your own, make sure you get them all to the same side, and then factor the quadratic. First thing I did was I moved this -3 to the right side by adding 3. And when I got that, I wrote x squared plus 3 equals -4x. Lastly was to bring this -4x to the left side by adding 4x. And the smart way of writing it is when you have x squared first, your x term, and then your number, because then that will look like the quadratic a, b, and a c. So you should have got x squared plus 4x plus 3. You also could have got -x squared minus 4x minus 3, but you would get the same thing. So you multiply a times c, which is a 3, and then your b term was a 4. List of factors of a 3 that would add to a 4 would be 3 and a 1. Again, this was a shortcut, so I could do x plus 3 and x plus 1, set each one equal to 0, and once you solve, you would have gotten x equals -3 as a solution and x equals -1. So that is how you factor a quadratic when the a term is a 1. And we are going to get to where a is not a 1, but that's a second video because we're running out of time. So if you will go ahead and stop this video and watch part 2, that's going to show you the most challenging problems when your a is not a 1. Okay? So thanks for watching.